Hey, what's going on, guys? Joseph Mills coming to you today with another episode of AutoMeter Garage. I am here in Crystal Lake, Illinois at Ultrastrobe Communications and Eby Graphics. Today, we've got ourselves a Jeep YJ to play with. And I know what you might be saying, the Jeep YJ, maybe one of the less loved Wranglers, but I got to tell you, this one here is a real piece of work. We've got a built small block Chevy swapped in here, but unfortunately the gauges are no longer working in this vehicle. Now that happened not because of the swap, but basically because the stock gauges in these are pretty much garbage. So we are here to rescue this restoration. We've got AutoMeter's YJ gauge kit. We've got a full drop-in replacement panel. We've got a harness. We have a tack, speedo, oil pressure, water temp, fuel level voltmeter, as well as an axle temp gauge, because if there's anything we are worried about potentially ever letting go on this build, it's probably that rear diff. So we're going to take you through step by step, do a complete installation of all the gauges on here. So stick around and we're about to start tearing into this thing. We're going to begin by removing the factory instrument panel here, and one of the great things about working on vehicles from this era is really they come right apart. So there's 6 screws in total holding it together. You've got one down here, and there's one in the same spot on the other side of the steering wheel. We have one up here, and finally one right here. So with all of our screws undone, we're going to slide this forward, and there's 2 little clips for the center indicator panel. You can kind of just reach in from behind, pull that off, and the whole piece drops right out. Now to remove the factory tack, literally just 2 Phillips head screws. I can't tell you how happy I am with how easy this thing comes apart. With factory tack and unscrewed, we use a little pick here to kind of undo the connector, and the whole factory tack comes out as one piece. Factory speedo comes out the same way, 2 little Phillips head screws. We pull this out, unhook that little connector in the back, and as you can see, the speedo cable was in really good shape up to this point, so that's the whole unit right there. Removing our center gauge panel is just as easy as the main piece. We've got 6 screws, 1, 2, 3, 4, 5, 6, and then one more right here that's exposed when the main panel is removed. Once that is out, the whole unit slides free, and we'll unplug the harness for the aftermarket radio. So on our factory gauge cluster, it looks like at one point in time there was probably 5 screws on it. We have 3 that we need to remove. But literally just a couple of screws, that pops out. Unhooking the connector is literally as easy as just squeezing the sides, and it all comes free. With our panels all removed, we're going to start wiring the vehicle, and we're going to simplify that process using this AutoMeter Universal 6-gauge wiring harness. Now, this is really cool because we've got one piece right here that we use to wire the vehicle. All the wires are color-coded, they're all labeled right on the wires what they are. So we wire the vehicle, and we've got a bulkhead connector, and then we can wire our gauges outside of the vehicle and literally just plug everything in. So that makes that a lot easier. Now, I said it's a 6-gauge wiring harness. We're installing 7 gauges in this vehicle, so our diff temp gauge, which has to travel all the way to the rear of the vehicle, is going to be done separately, and we're just going to integrate that into that connector piece. We've got a factory pass-through right here where we've run the wires through. This isn't a great permanent solution, so this is a nice thick piece of rubber. We're going to drill a hole right here to put all our wires through. We're going to start with a small bit and work our way up. This will be our pilot hole. All right, with our pilot hole drilled, got a big one right there. That'll be more than enough room to pass our wires through. Okay, so hooking up our fuel level gauge is actually very easy. On this vehicle, the fuel level gauge did sort of work before. It had an issue bouncing back and forth. So according to the wiring diagram, that is the tan or brown wire at pin 4 of the gauge harness connector. So we tested this with an ohm-meter to make sure that there wasn't an issue with the fuel level sender. We had nice steady resistance all the way through. So we're going to take this dark wire labeled gas gauge on our wiring harness. We're going to put 2 connectors on here, shorten the wire, and put those together. Just finished putting some crimp connectors on here, got a male and female, and we will plug those in together. We've got our wiring complete for our fuel level gauge. So fuse box is right under here. We used a multimeter to test things that come on and off with the key. We found a spot labeled, conveniently enough, ignition. There's a 15 amp fuse on there, and we're going to put said 15 amp fuse onto this cool little fuse tap. Drop that right in. We've safely got fused power for both the existing OE equipment as well as our new gauge cluster. After a very brief debate, we decided to follow a little of our own very time-tested advice. We actually extended our gauge grounding wire through the firewall, at which point we'll put a ring terminal and put this right on this carburetor bolt right here. There is no better ground anywhere on your vehicle than the engine. Your gauge is only a function as well as your ground is good. So we're going to make sure that we have the best possible ground so all of these gauges read as accurately as possible all the time. We're working on the wiring for all of the gauges. We've got them installed into the panels as well as the radio. We had to do just the tiniest bit of grinding to make this radio fit for the anti-theft sleeve on there. Very, very simple. One thing we always like to point out, so the harness connectors for the tach and speedo are not fully pinned. It's because we use different arrangements. On the back of the speedometer and the tach, the pin arrangement is engraved into the case. So we take these pins, we put them into the connector according to the locations on the back of the unit, and then we can plug those in. So that is all set to go right there. You can see all of our gauges are neatly put together. We have our ground wire run out to the engine. We've got power run to the fuse panel. Extra wires here that were included are for indicators, high beam, check engine, that sort of thing. We're maintaining the factory indicator idiot light panel, so these aren't going to be used. We've just looped those off, put a little bit of heat shrink on there. We've also included a key switch power and engine ground, which will ultimately power our GPS speedometer sensor. It's important to note that the ground wires for the gauge light grounds are separate. For best accuracy, we want to ground the lights for the gauges separate from the actual gauge grounds. So that's what we've done right here. We have these all onto a little stud. This can be just grounded underneath the dash. It doesn't need to go out to the engine like the gauges do. One quick upgrade we did was to install AutoMeter's white LED replacement bulbs. Now these have 5 LEDs integrated onto a little board that fits into the standard T3 style wedge. That's your 194, 168 style bulb. These are fully ballasted, which is cool because your conventional linear rheostat dimmer will work with the lights so they can be dimmed along with everything else, and you won't have to use a pulse width modulated dimmer. Moving on to our coolant temperature sensor, we actually have a 3/8 inch NPT port right on the Edelbrock manifold right here. Presently there is an old plug installed just so we could fire the motor to make sure it was running. So we're going to pull that out, but because the radiator sits up nice and high here, that's a lower pressure area, we are going to need to first drain a little bit of coolant out, and because there's no spout, we are probably going to make a little bit of a mess. With our coolant drained, we've gone ahead and installed both our 3/8 inch bushing right here as well as the temp sender. It's an 1/8 inch NPT. The official spec on that is 2 turns, past finger tight. We've touched on this before, but as you can see, the threads aren't going to bury down all the way. That's a tapered pipe thread, and we have a tiny bit of liquid Teflon thread sealant right there. Again, don't use the tape, as that will impede proper grounding of the senders and cause it to read too low, which is really the last thing that we want to have happen on a water temp gauge. Moving on to installing our oil pressure sender on the unit, because we've got a traditional Chevy small block here, we're going to install that on the back of the block, kind of over by the distributor. Now this vehicle has a fairly large HEI style distributor on here, so because of that, it can get a little tight putting the larger bell type sender. So what we like to do is use a little bit of braided hose. Now we've got an AutoMeter braided hose kit. You don't necessarily have to use an AutoMeter kit. This one's nice because it has all the necessary adapters that you need to do the installation. And because it's braided and all metal, the sender is still able to find its path to ground, so it reads accurately even when it's remote mounted. Our line is now installed onto the port next to the distributor. It's just an 1/8 inch NPT pipe plug on this particular engine. Sometimes they're 1/4 inch NPT. It just kind of depends on when the motor was made. So we've wrapped our braided stainless line with some really nice vinyl tape here. Of special note, the AN or Army Navy fittings on here should never have any sort of thread sealant Teflon tape. They will not leak on their own, but they will leak if you apply any sort of thread sealant to them. Not the case with our NPT. We have just a tiny bit of liquid thread sealant there. That's going to be tightened in. These are 14 millimeter or 9/16 will also do. And again, 2 turns, past finger tight. And we are set to go. So to remote mount our oil pressure sender, we stopped at our local hardware store and just got this simple piece of conduit bracket right here. Because we're using a braided stainless steel line, we're able to get the ground for our sending unit through that braided stainless line. So because of that, and to reduce some vibration, we're going to slide a little piece of heat shrink tubing onto the bracket, safety first here, and I'm going to go ahead and just shrink that down. We've got an already existing hole on the firewall that we're plugging up as part of this. I'm holding it straight while Brandon is tightening it on the inside. We got a lock washer and a locking nut. So we've run our oil pressure wire over, and as we've done on the other wiring, we've got that nice armored sheathing on there. We are going to crimp a ring terminal onto the end and just tighten that down there. And we'll run it behind this connector. And we've got a perfect spot right there for our sending unit. Probably a little hard to see with my hands in the way. And there's our sending unit. So we can just tighten this all down, and oil pressure sender is officially done. So we've got our tack signal wire right here. That's going to plug directly into the HEI cap. There's a tack terminal, so we're just going to go ahead and drop a spade terminal onto that, and that can be plugged in to the HEI. So we're going to wire up our water temp sensor. We've got a ring terminal right here. We're going to go ahead and crimp that on. Now, we do get a couple of questions about this, so I wanted to clarify. Ring terminal first, then lock washer, then the top nut. And we're going to install a ring terminal onto our main ground wire for all the gauges. As we've said, it is incredibly important that that be grounded directly to the engine, so we're going to use this stud right here. Now we're ready to run the wiring for our differential temp sensor. We've got some really nice armored conduit that we've run on these lengths of wire. So we have one very long length with quick connects on it that'll run up and pass through the firewall going to the gauges, as well as one short length with a ring terminal that'll go to our sending unit in the diff cover. This makes the entire setup nice and serviceable should the diff ever have to be removed, which, as we suspect, this is probably the weak link on the vehicle, is going to happen sooner than later. So we're going to run all of our wiring along the frame rail here and zip tie everything to the existing hard lines. Because this is a stock differential, we're dealing with a stamped diff cover rather than a cast one. Typically we would drop the cover, drill and tap it to install our sender. Because it's a stamped piece, we're going to be taking this off and brazing an 1/8 inch NPT bung into them. In order to get a bung onto our diff cover, we are going to have to remove it, and unfortunately this diff here does not have a drain plug, so we're probably going to make a little bit of a mess. I went ahead and broke all the bolts free already, because obviously you would not want to be using this long of an extension to break them loose. I just don't feel like taking a bath in gear oil today. All right, the moment you're all waiting for. Am I going to make a mess out of myself? It appears when this diff was serviced before, someone decided to put a metric ton of RTV in there. We're prepping our diff cover here. We've cleaned off all the paint and grime right underneath basically the fill hole there. We know that that's a good spot for us to measure temperature. Additionally, we want to make sure that all of the mating surfaces on the back of the cover here are nice and clean, so we've got a good mating surface for our RTV. With all those surfaces cleaned, we're going to use a center punch here and put our spot where we'll drill to weld in our bung. Okay, very important when we're drilling, we want to start obviously much smaller than we intend to go. So start with a smaller bit. Next step. And beautiful, ready to weld. So because I am admittedly a crap welder, we've recruited a little help to get the diff cover done here. So we've got our diff cover prepped here, and we've got a little bit of undercoating we're going to spray on this once it's installed. We've removed all of the RTV material from the inside here, and we're going to take our whizzer and kind of clean up this surface as well. All right, we're just firing on a nice bead of RTV on our freshly prepped surface. Diff side is clean. It should seal up nicely. So you can see here we've got a nicely prepped cover, nicely prepped surface here. We're going to go ahead and mate this up, start putting our bolts in. One thing to keep in mind when doing a differential temperature gauge is that the differential is typically not grounded on the vehicle. So we're going to install an auxiliary ground wire. You can see this one diff bolt right there. We clean that up real nice. We've got a ring terminal, and we're just going to install that right there. That'll make sure we've got a good ground reference for our gauge, because without an adequate ground, it would read lower than what we want it to, and that would be a big problem. So you can see our ground wire right here. We've routed this along with the factory wires. That's going to give us more than enough room for as the axle articulates. We don't want that to get tugged out. We've run that up. There's actually a body ground right up above there. So armored cable, that'll be all good. We've got some of this spray-on undercoating here. So we're just going to finish this up, a couple light coats. After giving our RTV a moment to tack up and dry, we're going to go ahead and fill the diff up with a nice quality synthetic gear oil. So we've got our diff temp wire run all the way from the back of the vehicle. We've got it onto this hose right here. Everything's zip tied. We have a piece that we've passed through our firewall grommet right here and a quick connect for easy serviceability. We can plug that in, and the harness for our diff temp sensor is complete. Okay, so this is our gauge side wiring harness, which is now totally completed. This is the bulkhead connector that goes to the engine side of the harness. This yellow wire right here matches up with the yellow wire we ran for our differential temperature. We have one more connector that we added on for our differential temperature gauge. We have both our power from the fuse box, that's our pink wire, and the black wire, which is our engine ground. Again, very important that that ground wire goes through the firewall, and that's actually grounded to the engine. We also have all of our LED lights right here, which have a separate ground wire. Again, we want to keep those separate for the accuracy of the gauges, and this, just being a lighting circuit, can be grounded inside the vehicle, hence the much shorter ground wire. So with all of that done, we are ready to begin fishing all of these through right here so they come up right behind the gauge panel. So now we're moving on to the business of installing our AutoMeter GPS speedometer sensor, right? Super easy way to make our speedometer work. Doesn't matter if the wheels and tires change, doesn't matter if the gears change. It never needs to be calibrated. We just plug it in and it works. So this we're going to stick up underneath the dash. We have a small micro antenna right here. This is magnetic. And we're just going to stick that right there, as this particular Jeep is never ever going to see a day with a top on it. In fact, it doesn't even have a top. So we take our little wire and we've zip tied that along with this piece of wiring conduit that's already on the vehicle. It's nice, it's safe, it's out of the way, and it's totally functional. We've gone ahead and tidied up all the wiring behind the dash, just kind of strategically zip tying things in place so it looks nice, clean, and factory. We've supplied power and ground to our GPS module, which we've tucked up underneath here, and we've run that signal wire to our speedometer. Important to note, these connectors for the tach and speedo, we do want to make sure that those are seated nice and firm, so we've got a good connection there. And once that's done, we can literally just slide the panel up into place. Now you can see it's actually quite a tight fit on there. The tolerances are real nice, and that looks quite factory. So we'll screw that into place, and I think we're just about ready to start her up. All right, the moment of truth here. Let's fire her up. All right. Tach's working nice, great oil pressure, voltage is showing up. We're just about out of fuel, so we can't run it for too long, but yeah, they look great. Let's check the lights here. LED lights looking awesome. That's pretty incredible. All right, guys, our Jeep YJ has been an outstanding success. So gauges look great. Now we know for certain that this motor is indeed nice and healthy. So we got to consider this one a success. So guys, as always, thank you so much for watching. This is Joseph Mills, the AutoMeter Garage.